All right, guys, so now we have moved on to natural logs. So natural logs is what we did on Thursday. So remember with natural logs, we use the exact same properties that we used with our regular logs, okay? So in order for us to solve this, we're going to do the exact same thing. So first I'm going to rewrite this with the exponents. So I'm going to have the natural log of x cubed, because I'm bringing this 3 over, plus the natural log, now I'm moving this over, of 2 cubed equals 5. Now I'm going to combine my natural logs, and I'm going to get the natural log. So we're going to go 2 cubed times x cubed. So 2 cubed is 8, so I'm going to have 8 here, and then x cubed equals 5. So now my natural log is a single expression. So in order for us to solve for this, we're going to have to raise e to the power of this natural log 8x cubed and this 5 on both sides so that the e and the ln can cancel out. So I have e to the ln 8x cubed equals e to the 5. So remember, the e being raised to the ln cancels out, and I'm going to have 8x cubed equals e to the 5, or to the 5th power. Now, e, remember, is a number. It's like 2 point something. So we're going to solve knowing that. What I'm going to do is I want to isolate my x, so I divide both sides by 8. Let's bring this over here. So I have x cubed equals e to the 5th divided by 8. I'm going to take the cubed root of both sides because I want to get rid of this. So then I'm going to have x equals, so plug this into your calculator. When you do, you should get about 2.64. And on your test, I'll tell you what to round to. But that right there should be your final answer. For this next equation, I have e that I need to get rid of to solve for x. So first thing I want to do is I want to isolate my e, and to do that, I'm going to divide both sides by 4. Kind of like on the other one, how we wanted that one single natural log expression, we want to do that here as well. So I'm going to have e to the x minus 1 equals 64 divided by 4, which is 16. Next, what I'm going to do is I'm going to then take the natural log of both sides. When I do that, the ln and the e will cancel right out, and then I'll just have this exponent. So x minus 1 equals the natural log of 16. Once again, I am solving for x, so I'm going to add 1 to both sides, and I'm going to get x equals, let's divide that, 1 plus the natural log of 16. And when you enter that into your calculator, you should get about 3.7725. All right, guys, next we're going to be looking at growth and decay. So I have 2 equations here for you, and we're going to determine if they represent growth or decay and what the y-intercept is. So the exponential form, we have y equals ab to the x. So remember, a is our y-intercept, and b is what tells us if we have growth or decay. So we have growth if our b value is greater than 1, and we have decay if our b value is less than 1. So what you want to do is we'll look here. So we have y equals 2.25 times 1/3 to the x. So since we have 1/3 as our b value, that is less than 1. So this equation here represents decay. We have 2.25 as our A value, so that means that our y-intercept is 2.25. Next we have y equals 0.2 times 3.8 to the x. So our b value is 3.8. It is greater than 1, so this represents growth. Our a value is 0.2, so that means that is our y-intercept. And that's it. All right, guys, so we're going to start by graphing an exponential equation. So the first thing that we want to do when we graph the exponential equation is we kind of want to graph its parent. So I'm going to make a table of values for the parent of this graph, which is going to be y equals 5 to the x. So I'm going to plug in values -2, -1, 0, 1, and 2 for x. And then my outputs. So 5 to the negative second is 1/25. 5 to the -1 is 1/5. 5 to the 0 is 1. 5 to the first is 5. And 5 to the second is 25. Alrighty. So next, what we're going to do for this is we're going to make a sketch of the parent. So we're at -2. And I'm going to go up 1/25, and so I'm just going to put a dot right on the line there. -1, I have 1/5, so I'm going to go a little bit higher. 0 and 1. And then I have 2 and 25. And 25 is going to be all the way up here in the stratosphere, so I'm just going to put my dot right there. So right here, I have the graph of my parent function. All right, my parent function being y equals 5 to the x. Next, I'm going to graph the stretch. So the stretch right here is -2. Let's see if I can get a better marker. That's blue. So in order to graph this stretch right here, what I'm going to do is I'm going to multiply all my y values by -2. All right? So then I'm going to have, let's see, -2 over 25, -1/5, -1, -5, and -25. So now I'm going to re-graph this by using my same x value, but now I'm going to use my new y value. So I'm going to have -2, and now this time I have -2/25, -1, -1/5. We have 0, -1. We have 1, -5, so 1, 2, 3, 4, 5. And we have 2 and then -25 all the way down here. So now notice how this stretch flips our graph over the x-axis. Lastly, I'm going to take each of these points and I'm going to translate them 3 units left. All right? If I had another thing going on over here, like it was like plus something, then I'd be going up or down. But since I just have a +3 right here, that just tells me I'm going to go 3 units left for my last translation. So I'm going to take every single point and move it 3 units to the left. So I'm going to move this over 1, 2, 3, right here. 1, 2, 3. 1, 2, 3. Down here, 1, 2, 3, 4, 5. 1, 2, 3. And then my 25 all the way down here in the stratosphere. So my final graph will look like this. All right. So y to the negative 2 times 5 to the x plus 3 is going to get me this black graph right here. So my suggestion for your steps is first you want to graph the parent, then you want to multiply the y value by the stretch, regraph it, and then lastly take your points and translate them, shift them to where they need to go. So now that I have my graph here, I can now tell my domain, range, y-intercept, and asymptote. So if I look at my domain, all right, now remember our domain is our x values. So our x values are going all the way to infinity to the left and then all the way to infinity to the right. So that means I'm going to have x is, so that means I'm going to have all real numbers. Now my range, I'm not going past 0 here. I'm going all the way down. So everything below 0 is fair game, but nothing above 0. So for my range, I'm going to write y is less than 0. The reason why I'm saying it's less than 0 is because it's never going to actually reach 0. Lastly, second to lastly, my asymptote. So your asymptote and your range kind of go together here. So we see how y can't pass this line. So what line is this? This is your x equals 0. This line right here is the line our graph will never pass. That's your asymptote. And then lastly, you have your y-intercept. So let's see. So for my y-intercept, this one's a little tricky. Just look and see where it goes through on your graph. In this case, I'm honestly not 100% sure because of like how it looks. On yours, it will be exact, but whatever value it goes through the y-axis right here, that is your y-intercept. So I'm going to say for this specific one, see graph. This was a little tricky, I'm sorry. On your test, it will be a lot more obvious what your y-intercept is. But anyway, here is how you graph an exponential function.